Hi everyone, I'm Stephen Taskin and welcome to one of my presentations on Revit Conceptual Meshing Design Environment. This exercise was part of my presentation at the Revit Technology Conference held in Los Angeles this year. This example is a basic use of a controlled extrusion, twisting and tapering in conceptual meshing environment. Now let's have a look at the concept itself. This is the proposed Okta Center project, which is located in St. Petersburg, Russia. The tower has been designed by RMJM Architects. Let's take a closer look at the form itself. The tower has been formed by 5 equal squares, which is radially located around a circle. For that reason, I will be using 2 circles to create the form, extrusion, twisting and tapering inside Revit Conceptual Design Environment. Let's start the exercise. First, I will be placing a reference line onto the default reference plane. This line will become my rotation arm, and I'll just place an angle measurement for this and turn that measurement into a parametric value. Place it under instance and constraints. Now the next step is creating 2 circles which will be rotated by this arm. So I'll select the semicircle tool, make sure I set the reference plane of that line and then lock the 2 ends of the semicircle to the end point of that reference line. Just turn the radius dimension to a permanent dimension and then create the next parameter as the radius of this circle, and then finishing off the remainder part of the circle. So now we'll repeat this step for the inner circle. So 2 circles. I'll just zoom in to be able to see the pad looks a little bit clearer, and then turn that dimension into a permanent dimension as well, and creating the parametric value for the smaller radius, and making sure I finish off the remainder of the inner circle as well. So we now have 2 circles. It is really critical to flex this 2 circles immediately after this step to be able to make sure circles are rotating without breaking. So as you can see, rotation angle 30 degrees and circles are rotated accordingly. As you can see graphically, they do rotate without breaking. So next thing is to create a mathematical relationship between 2 circles. For this I have prepared a formula earlier on, which is based on trigonometric relationship between these circles and the squares. So if I apply that, I'll just change the outer circle to be just a bit smaller, 20 meters, and now we have 2 circles which they are related with each other as a function. So the next step is breaking these circles into 5 equal segments by using points. So I'll just place points roughly breaking this circle into 5 equal segments. I'll just use the filter tool and make sure I turn the measurement type to angle, reselect the first one, and I'll go to the nearest full angle dimension, 90 degrees. So those points should be located 72 degrees away from each other to be able to divide this circle into 5 equal parts. I just changed the measurement end so I could use the same values as the other side. So turn that into 18. Okay, we've got the first outer circle done, and then we'll go and start doing the next set of points, and then of course the first point located in the inner circle is relatively in the center of the outer circle segments, so I'll just turn off the other categories and turn the measurement type of these points to angle as well. Reselect the first one, that should be 54 degrees to sit in the middle, and then relatively should follow the same 72 degree angle separation. This one is spot on. Change the measurement end, that should be 18, and then change the measurement end, and that should be 54. And now we have the inner circle with equal 5 points or segments. Now the next task is joining these points with model lines. For that, make sure you turn your 3D snapping on, and then draw the lines between the points like so. So if you look at the plan view, now we can see that we have created our basic floor plate, and I also want to make sure the rotation arm is still functioning without breaking the family. Okay, everything is perfect. So next step is just starting another conceptual massing family. Go back to the original family and load back that into this family. Make sure you place on work plane turned on and place the shape to the default intersection. Next thing I'll be doing is just copying the shape and creating 2 more levels. So just placing some height dimensions, so I'll just get the first one and second one, and I'll make sure this one is 200 meters tall. Again, there is no, I haven't done any study about the size of this tower or what the dimensions should be. I'm just making them up as I go. So there you are. So we have our basic heights for 3 different floor plates. Next thing, I'll just select all the families and make sure the rotation angle is 0. So go back to a straight form and start selecting the lines out of the first family. So you have to make sure you select the lines rather than the family itself. So for that, just use the tab key. Depending on your approach, sometimes it picks the lines straight away and sometimes it needs to be like here. Hit the tab key again, and lastly we'll repeat the same exercise in the top shape. And it's something that it needs to be done carefully without picking the family itself. So okay, well, I'm picking all the edges. Now we'll select create form, and we created our basic extrusion. So next thing, I would like to twist the form. So I just pick the middle floor plate and twist that by 50 degrees, and then I'll pick the top form and twist that by 90 degrees. So we've done our extrusion, we've done our twisting and or rotation if you like, and next and last thing I will be doing is changing the scale or tapering of this form. So I'll turn that into 22 meters instead, and then we'll pick the top form and turn that into something as small as 300 millimeters. And voila, there you are. Now we have a form in our conceptual massing that has been extruded, tapered and twisted. And please make sure to watch the second part of this video for curtain panel creation and application of this exercise. Thank you.